My name is Alan, and welcome to my video on the XRP Ledger. So today we're going to be discussing hashing and other methods of encryption. Hashing and encryption are both methods of securing data. In essence, hashing involves taking a string such as this hello as an input, then outputting something completely different from the original. We have a set of characters that formulate a string. This string is then passed down into a hash function. Once the string is passed into the hash function, it outputs a set of characters or a new string that is completely different from the original. Now, the pattern of the output is going to completely depend on the hashing algorithm that you choose. This is an example of how a SHA-256 algorithm might look like. Of course, there are more algorithms such as SHA-3, bcrypt, MD5, and SHA-256. Now you may be asking, what's the point of a hashing algorithm and why do we need it? One good example can be securing data in a database. Let's say you have a database that stores the passwords for your users. We have Bob, Mike, Eve, Adam, Millie, and their corresponding passwords. Having the password stored in plain text is a severe security vulnerability because there can be malicious actors. Let's say we have this malicious actor and he finally has access to your database. He would automatically have access to all your passwords. So how can we prevent this? This is where hashing comes into play. If we were to store it as a hash, this data would be completely useless to the malicious actor. Why is that? Once we receive a hash value, that hash value cannot be converted back to its original value. In order to do this, you would need an extremely computational expensive process, even a quantum computer, to even crack the value. And that makes storing passwords ultra secure. Because once you receive the hash value from the input, the hash value cannot be converted back to the original input. So in other words, our evil malicious actor has useless data because he has no way of converting it back. This would require computationally expensive processes and even a quantum computer. Okay, so I've opened up a hashing algorithm calculator. We're using SHA-256. And I'm going to show you an example of how does it look to encrypt. And I'm going to show you an example of how it looks when you hash something. We have this JSON, we stringify it and pass it into the hash function. It produces a hash value as an output. Now, if I were to make a single change, like a minuscule white space, that will result in a completely different hash value. These are changes that are naked to the human eye, but the hash function allows us to see them. This is very important because not only are we able to securely conceal the data, but we're also able to detect whether or not the data has been changed in any form. Now, another interesting property is that you can increase the length of the input. I duplicated this 3 times. But no matter the length of the inputs, whether 20 character or 100 characters long, the output length remains the same. Since we have covered hashing, let's now move on and discuss encryption. There are 2 types of encryption that I want to discuss today. Of course, there are more, but these are the most common ones, such as symmetric encryption and asymmetric encryption. Let's discuss symmetric encryption first. Symmetric encryption is similar to hashing in that it uses cryptography to get an output that is completely different from the input. That's where the similarities end. Symmetric encryption involves taking an input such as this tower string and using a key instead of a hash function to convert it into a string that is completely different from the original input. You can think of a key as a set of instructions for a cryptography algorithm to change and morph your data. This key knows how to morph and change your data, in a way that you could decrypt later. By using the same key, you could turn the scrambled data or encrypted data and decrypt it back to its original input. And that's how symmetric encryption works. You have one key for encryption and you use the same key to decrypt. Now, asymmetric encryption is similar, but instead of having one unified key to do the encryption and decryption, we separate them into two different keys. We have a public key and a private key. We use the public key to encrypt this tower string. Once the data is encrypted using the public key, it can only be decrypted by a holder of the private key. Millie uses Bob's key to encrypt this data, then sends it to Bob. Bob reciprocates and does the same thing. Now, if a malicious actor such as the FBI got a hold of the data packets or the stream of data containing their message and decoded it, it would be completely useless to them because they are not able to see any text that is recognizable or readable. Let's demonstrate how encryption and decryption works. I'm currently using the RSA algorithm. Let's generate a key pair. Okay, now we have our key pair. I have the private key and public key. So let's say I want to send Millie as Bob a new message. Hello. How is your day? We can then now encrypt that message and receive a encrypted value. In the analogy that we had before, we would send this through a network so that Millie can receive it. Once Millie receives this message, because she has the private key, only she can decrypt the message and see its contents. Let's paste this into the decryption space and decrypt the message. Now we get the decrypted output, which is hello, how is your day? This is my video on hashing and encryption, and I hope you guys learned something. I'll see you then.